Protocol gateways are small devices that function as translators for various protocols and physical layers. This allows machinery, sensors, actuators, and computers to communicate with one another, despite their difference in protocols and physical layers, making protocol gateways essential in connected industrial facilities such as factories, power plants, and dams. Given its critical role, we set out to investigate the protocol gateway's ability as a technology to translate industrial protocols in difficult scenarios, for instance, when faced with malformed traffic, akin to traffic that malicious actors purposely create. To do so, we created a security test setup that included a fuzzer that generated the inbound traffic for the gateway under test, a simulator that simulated the receiving station, a sniffer that collected information on the outbound traffic, and an analyzer that collected both inbound and outbound traffic for the analysis. The major finding we have in this test is the discovery of the condition wherein the protocol gateway will forward certain packets without translating it. Whenever there is a packet that has an incorrect length value than its actual length, the protocol gateway will forward this packet as is. This is dangerous, as an attacker can use this vulnerability in order to stealthily effect change in a target system. To demonstrate the danger, we designed a Modbus TCP packet that satisfies two conditions. Even though initially it was sent as a Modbus TCP packet, it will also read as a valid Modbus RTU packet as is. Read as a Modbus RTU packet, it has a completely different meaning when compared to the original Modbus TCP command. Since the packet is blindly forwarded, what was originally a Modbus TCP command to read the value of a memory address, is now interpreted as a Modbus RTU write multiple coils command. In this scenario, the coils or switches of the relay, thermometer and tachometer were turned off. Normally, values such as a critical threshold can be modified by issuing a write register command. However, we found that one data station allows the memory of the register to be written by a write coil command, which should not be the case. This allows an attacker to issue a write coil command in order to set the critical threshold to a dangerously high level, which can destroy the product or equipment itself, or set the critical temperature too low, triggering an alarm and possibly disabling the operation. We found that every time the internal service program in the protocol gateway restarts, the random ciphers used to hash the password are reused, thus becoming predictable. We used recorded packets from a rebooted and relaunched protocol gateway to prove this. Analysis showed the same cipher repeating again and again. By replaying the cipher, a hacker can gain access to the protocol gateway without having to know the text of the password. Even if the cipher is properly randomized, we were able to intercept the encrypted configuration transmitted over an Ethernet connection. Since the configuration also contained the encryption key, we were able to decrypt it as seen in the video, allowing us access to database files. Logging into the protocol gateway's web interface as a regular user, with no privileged access, we opened ping test where we instead copied and pasted the command that will allow us to run a telnet daemon in the URL. We were then able to obtain full remote access to the device without having a privileged user's credential. Reaching this point, we were able to exfiltrate the configuration files, highlighting the impact of this vulnerability. To demonstrate how weaknesses in a protocol gateway can affect a system, we tried simulating a denial of service scenario. We instructed our fuzzer to generate malformed packets. This eventually caused resource exhaustion for the gateway, as evidenced by the website failure. One of the protocol gateways we tested also demonstrated a susceptibility to DOS attacks. We found that sending specially crafted malicious Modbus TCP packets could remotely trigger a reboot for that device.
Protocol translation vulnerabilities and device vulnerabilities found within protocol gateways result in denial of control and denial of view conditions. As protocol gateways play a crucial role in industrial facilities, securing these devices help to reduce the threats within industrial facilities.
For more details and insights on protocol gateways, visit www.trendmicro.com, and read our research, Lost in Translation, When Industrial Protocol Translation Goes Wrong.